Okay, so today I am teaching Danny, dot product for angle between and amount along vectors. So what we're going to be learning here is, here's a 3D shape here. There's two ropes, right? There's a force being applied on this one, and we're going to find the angle between the two ropes. That's this part. And the amount of this force that's being applied from A to C. Right. And so these are the two equations we're going to use. We're going to find the angle first. And so the way to do that, you're going to take the cosine inverse of the dot product of these lengths, the magnitudes of the ropes, right, over the product of the magnitudes of the ropes. And so the first thing you need to do is find the length of these ropes. And we're going to start with AC, from A to C, in vector notation. And so we're going to go from A to C first. So in the X direction, the rope, to get from A to C, you're going to have to go -8 feet. I'm sorry, that's wrong. Good start. -6.
Yeah, you go -8 in the Y.
Right, correct.
Yeah.
-6 is in the X because that is in line with that. No, +2. Okay, so let me be clear. These are hard to look at sometimes, but we're going from 6 to 8. Therefore, correct.
Yeah.
Therefore, we're going in +2 feet in the X direction. Right. In the Y, we're going from 8 feet back to 0. So -8 j hat. And in the Z direction, we're going from 0 to 10. So +10 k hat. Right, that's our that's the vector notation of the length of this rod. So the magnitude of the length of that rod, which is going to be the length of that rod, is the square root of all those numbers squared. It's going to equal out to about 12.96.
That's the length of the chain.
Correct. That's in feet. That's the length from A to C. Now the length from A to B in vector notation. In your X direction, you're going to travel from 6 to 0. So you're going to go -6. And in the Y direction, you're going to go from 8 to 10. So 2 j hat. And in the Z direction, you're going to go from 0 to 4 k hat. So the magnitude from A to B is going to be the square root of those numbers, which is 7.483 feet. So that's the length of the rod from A to B.
Yeah.
Right. Which is, magnitude can be like an amount of force or an amount of length. Does that make sense?
Yeah, so in this case,
Okay.
it's just.
In this case, since that's R, that's what that R means. It's referring to the length and not the amount of force. And so now we have all the numbers we need to apply to our equation. And so theta is going to equal the inverse cosine of the vector notation, the dot product of the vector notation over the sum of, or the product of the two magnitudes. And so in order to do a dot product, you're going to multiply the x's, add that to the, you're gonna take the summation of each thing multiplied together.
Summation of those.
Right, so you're gonna take 2 times -6 plus -8 times 2 plus 10 times 4. Right? That's the dot product of A to C and A to B.
Yeah.
And then the product of the magnitudes is going to be 12.96 times 7.483.
So your numerator is just always going to be your vectors, and it's vectors because that spells the I hat and the J hat in it. Until
Correct.
you multiply.
Right.
But
Once
that's-
once you do this math, it's going to come out to a degree,
Yeah.
and so these go away. These labels go away. But dot product, that's what dot product is.
It's the
You multiply.
product
You
of
multiply in vector form.
Yeah. Okay.
You take it one by one.
Yeah.
So when you do this math, theta is going to equal out to 82.893. So that is the angle right here. This angle. It's the angle between the two rods that are in completely different directions.
Yeah.
And so now we're going to move on to the amount along. And so this is kind of a hard concept, but essentially what we're doing here is we're going to calculate the amount of force from this F that is being applied in the AC direction,
Yeah.
exactly in that direction.
Yeah.
And so what we're going to do is we're going to take the dot product of the force
That
vector of AB, right? That's going to calculate everything in the AB direction and multiply it by the unit vector of the AC direction.
Yeah.
And so, and that's going to calculate the amount of force
Going in that direction.
going in that direction. And so, okay, to calculate this part, we're going to start with this part, right here. From A to B, right, it's going to equal the magnitude, which is 12, times the vector notation of the direction. I hat plus 2 j hat plus 4 k hat divided by the length of the hypotenuse,
Yeah.
which is going to be the square root of 6 squared, 2 plus 2 squared plus 4 squared. But since we already calculated that, we're just going to put that. Right? And so that notation, those answers are going to be -9.62 I hat plus 3.207 j hat plus 6.414 j hat.
Because you just do that by taking your -6 divided by your 7.
Correct.
24 times 12, so
Yep.
your I hat and then do that.
Yep. Yep, it's this number times 12 over 7.
Yeah.
This number times 12 over 7, that number times 12 over 7.
Yeah.
Gets you those three. And you leave it, this is vector form, so you're going to have an I hat, a J hat, and a K hat
Yeah.
still. And so that right here is the first part of our equation.
Yep.
And now we need to find the second part, which is the direction, what we're going to multiply this by to find how much of this is going in that direction. And so to find the unit vector, AC, we're going to take it's essentially the same thing except there's no magnitude with it.
Okay.
And so it's going to be the direction, the vector form of the rod from AC divided by the hypotenuse, which is the magnitude, the directional magnitude. And so the denominator is just the square root of 2 squared plus 8 squared plus 10 squared right here. We already calculated that, so I'm going to erase this. And I'm going to put in 12.96. And so when you do that math, when you take 2 divided by that, 8 divided by that, and 10 divided by that, you're going to get 0.1543 I hat minus 0.6172 j hat plus 0.7715 k hat. And so now you have the vector notation for the force from AD and the unit vector of AC. And you're going to take the dot product to find what we need. And so what we're doing here, we're going to find the force that's going in the AC direction. We're gonna multiply like this. So what we're doing here, this is the I hat, this is the J hat, and this is the K hat. Right? I took those numbers, and that's what dot product is. And so when you do that math, and when you do this, you lose the labels, right?
Yeah.
You're gonna get 1.48 approximately, and that's in pounds. Because in the context of our problem, we're calculating the amount of force from that F direction, or that F force that's in the AC direction, and that amount is 1.48. So those are your two answers.
Yeah. For the angle